role here. Now, as much as we then dealt with perpendicular vectors, it is important to note that sometimes we need to deal with the vectors whereas they are actually acting on an angle. So here's a good example where a vector is acting, let's say, on an angle of theta in this case, and this vector, let's call it f, okay? This vector is actually made up of two components, respectively, the horizontal component going in that direction, which we can call fx. Now we are determining the components given the force and the angle. So fx and the vertical component called fy. Please note, these two are still perpendicular to one another. So it's a case of when fx is going in that direction and fy is going in that direction, when they collide, they actually make this f that we are given in this case. So we now want to work backwards and determine these particular components, okay? Vector components. So from our, depending on where our theta is, okay? Sometimes they can put theta there. In this case, let me just put beta. And I will start by explaining theta only, then explain beta from this one. Okay, so if I'm using theta, which I advisable, okay? The advisable approach is to ensure that you're using the angle from the horizontal, the angle drawn from the horizontal. It will always be a complement of the angle drawn from the vertical. The reason for this is that if you're using this angle from the horizontal and you're looking, let's say, for the fx, you will have cosine theta, since fx is adjacent the angle and f is the hypotenuse. So you get cosine theta is fx over f, giving us a general approach that fx will always be f cos theta, always only given that the angle is to the horizontal instead of to the vertical. And similarly, sine theta, let's erase this part. Sine theta is given as fy, since it's the opposite. Remember your SOHCAHTOA. Sine is opposite over hypotenuse. Opposite is fy over fx, meaning that if you're looking for fy, you'll always use, sorry, over f, not fx, hypotenuse, you'll always use f sine theta, given that the angle is to the horizontal. Please note, if you decide to use the beta, these things will be swapped around, where the fx using a beta would be f sine beta, because in this case, the opposite will be your fx, and the adjacent will be your fy, and your fy would be f cos beta. Okay, as much as it is correct, it's just easier then to frame one way to say, let cos represent my horizontal. And, okay, so let's change this into an applicable problem, typical exam problem, an actual loan problem. Just a simple one first. Let's start very simple. Let's not go too difficult. We are given a force acting, maybe it's about 20 Newton force, acting at an angle of 30 degrees. and you need to determine its horizontal component and its vertical components. The horizontal component fx would simply be 20 cos 30 degrees, and the vertical component fy will simply be 20 sine 30 degrees. The sine 30 is quite easy because we know it's a special angle from maths, so this is 10 newtons up. All right, you can see that the actual force, the mother force, is going upwards and to the right. So you can't then have down and left. So it's up, and this one would be 20 cos 30, and you'll get 17.32 newtons to the right. Now, before I make this question very complex, it is important to get this analysis of the effect of theta on fx and fy, meaning the components, the perpendicular components of a force. The effects are as follows, okay? If I'm starting, first things first, with fy being vertical, straight vertical, and then this being like that, okay? Let me do this actually first. If I start with, let me draw the box, and let's draw the force. Okay. The force, let's start halfway. And let's call this 45 degrees. At 45 degrees, the value of fx will be the same value as fy. The reason it will be cos 45 is exactly equal to sine 45. So the vertical and horizontal components are therefore the same. Now, if I make the angle a little bit smaller towards the x-axis, let's say I now make the component here at 15 degrees, you'll realize that fx should be greater than fy because the x component increases since the actual vector is very closer to the horizontal. And the closer this is, in this case, we can even say that f approaches fx. When you make this angle smaller, so when theta approaches 0 from the horizontal, when the angle gets smaller, meaning approaching 0 degrees, we can see that the actual force gets very closer to its value of its x component. And the opposite then is true. To say, if I have the force acting on a very large angle from the horizontal, say 80, right? So 80 degrees. You can already see, if you were to draw a vector, that the horizontal vector will be very small. So in this case, the horizontal vector will be less than the vertical vector. And we can say as theta approach 90 degrees, then the force approaches, and I'm actually writing these ones wrong. It needs to be fx approaches the force. So here, fy approaches the force. So fy gets bigger and closer to the actual force. Okay. It's a beautiful question. While you're at that, yet again, I'll allow you some time to work. So all we need to do is to first resolve each of these vectors acting on an angle to their components so that we can have the FR resultant, meaning horizontal result, FRX and FRY, resultant in the X plane and resultant in the Y plane. So another beautiful way of actually doing this is doing it like this, checking X component and this side, all right, Y component. So similar to a table method approach, if you are taught by either Miss F1, let's deal with F1. We are looking for the X component of F1. Now, remember, they gave us the angle to the vertical. If you want to maintain cos as your X component, then you can use 50 degrees for F1. And then for F2, you can use 60 degrees so that cos will always be for the horizontal component. So this side for F1, we have this as F cos of 50 degrees. And that gives us the F is 100 cos of 50. And I'm getting 64.28
28. Yes, sir.
newtons to the right.
Right.
And then this side, it is actually the force. Force is actually 100, so we're happy here. This side will be
So
the, yes?
the method I used is the beta method.
Yeah, that is fine. If you use the beta method, you used,
Sine.
yeah, sine 40. Remember, cos 50 is exactly equal to sine 40 because they are complementary angles. Do you remember on what's this? Mathematics, cos 50 is equivalent to sine of 90 minus 50. 90 minus theta. This is the 90 minus theta complement in mathematics, which then becomes sine. Okay.
Sine 40.
So these are identical to each other. Okay.
Yes, sir.
Perfect. So this side, then your sine 50, just change that to sine 50, and you get 76.60 newtons up. Okay.
Yes, sir.
And then we look at the components of F2. This one will be 80 cos 60. Cos 60 is a half, so this is 14 newtons to the right as well. And this one will be 80 sine 60 degrees. And you get 69.28 newtons down. Okay, let's up and right. Be positive, just a disclaimer there. I'm working with that. And then we go to F3. F3, I'm dealing with a 90 cos 20. It is already on the horizontal or to the horizontal, so I'm not stressing. 90 cos 20, and you get 84.57
57.
newtons to the left and 90 sine 20 degrees. And you get 30.78 newtons down. Okay, you'll realize that just looking at F3, the argument that we made on the previous one, that the smaller the angle, the closer the x component gets to the actual force. Do you see this? X component is 84 and the actual force is 90. So it's a good analysis to make. Okay. They like that type of analysis question. Now we can then get the FR in terms of FRX. This would be 64.28 plus 40 minus 84.57. And you get your answer. This side, FRY, would be 76.6 minus 69.28 minus 30.78. Okay, let's get to our calculators quickly. 64.28 plus 40. And
It's 19.71.
That's what I got too, sir.
perfect. 19.71 newtons. In which direction?
To the right.
This is FRX. FRY, please note, you'll get 76.6 minus 69.28 minus 30.78. And you're actually getting a negative 23.46 newtons. This means
So
that you can't say downwards yet with the negative effect. So it is a positive 23.46 newtons down. You can't put the down and the negative in one line. They cancel each other out. Very important.
Yes, sir.
this one.
So that means we've boiled down to only two forces then. We've boiled down to a force to the right of 19 newtons, 19.71 newtons, and a force down, which is actually slightly larger than that, of 23.46 newtons, meaning that our resultant is actually in that direction, and the angle is right there. I always like by starting during the horizontal vector first. It makes my life easy. F net is therefore the square root of the 19.71 squared plus the 23.46 squared, and you get your answer as
30.64.
Okay, just want to make sure
30.64.
30.64 newtons, and the angle theta will be the arctan of the opposite, in this case, opposite according to my diagram, 23.46 over the adjacent, the 19.71, and you get arctan 23.46,
49.
and you're getting 49.96 degrees, meaning that F net is actually equal to 30.64 newtons at 49.96 degrees